Hello everyone, this is Naveen Kumar from Aeronautical Engineering and the bearing rule number of 21955A2106, and today my topic is about flight vehicle design and for optimization for the starting process of turbofan engine under high altitude and environments. And in the starting process of turbofan engine in a altitude environment presents a unique challenges due to lower air density and reduced oxygen content at high altitudes. Efficient and reliable engine starting is a crucial for aircraft safety and performance. Optimization for the starting process of turbofan engine at high altitudes in an environment involves several considerations. uh, Whereas for a start, there are different considerations while taking. One is the starter selection. In this starter selection, we are going to discuss how choose an appropriate starter system, such as an air turbine starter (ATS) on an electric starter based on the altitude and specific engine requirements. The starters the starter should be capable of delivering sufficient torque to overcome the high altitude conditions. And another key factor is starter speed control. In this starter speed control, optimize the control algorithms for the starter motor to ensure that it provides the required speed and torque for the engine to spin up despite and reduced air density. In this may involve adjustments in the starter's speed profile. And the another key factor is air supply. In this air supply, ensure a stable and adequate supply of air for a starting process, especially in a low density, high altitude environments. These may involve modifications to the air supply system or the use of reservoirs to provide a constant source of compressed airs. And another key factors are ignition system. In these ignition systems, optimize the ignition system to provide a reliable and timely ignition of fuel to air mixture in the combustion chamber. High altitude starting may require adjustment to the ignition timing or the use of high energy ignition systems. And the another key factor is fuel delivery. In this fuel delivery, adjust the fuel delivery system to account for the reduced oxygen content in the high altitudes environment. Optimize the fuel to air ratio to ensure the efficient combustion and prevent the flame out during starting process. And after a fuel delivery, we're going to discuss about control algorithms, develop or fine tune control algorithms that take into account altitude specific parameters such as air density and pressure and temperature. These algorithms should be adapt changing environmental conditions to ensure the successful start. And monitoring and feedback, implement the sensors and monitoring systems to continuously access the performance of starting process. And these feedback loops should be triggered uh, trigger in a corrective actions in the case of anomalies and unexpected conditions. And in anti-icing systems in this cold high altitude environments, ice formation and engine components can be a concern. Implement the anti-icing system to prevent ice accumulation on critical parts like inlet and the compressor blades. And another key factor is about pre-start checks. Conduct the pre-start checks and diagnostics to ensure that all systems are ready for starting. High altitude conditions can be unforgiving, and identifying issues before starting can prevent for a critical failure. And the other key factors is safety and redundancy. Implement the safety features and redundancy in this critical system to handle any unforeseen situations during starting process. This includes backup starters, emergency ignition systems, and safety interlocks. And coming to simulations and testing, use advanced computational fluid dynamics CFD and finite element analysis FEA simulations to model the starting process under high altitude conditions, and conduct extensive ground tests in altitude chambers to validate the starting processes. Training and procedures. Training and procedures. Train aircraft maintenance and ground crew in high altitude engine starting procedures, safety protocols, and troubleshooting techniques are specific to the conditions at hand. Optimizing the starting process of turbofan engine under high altitude conditions is a complex engineering challenge that requires combination of advanced technologies and precise control systems and a deep understanding of aerodynamic and thermodynamic principles involved. The goal is to ensure safe and reliable engine starting in these challenging environments, contributing to overall aircraft performance and safety. And these are the primary factors which which are the areas to we need to work to optimize the starting process of turbofan engine at a high altitude environment processes. And the first one is about this starter selection, and the second area is about starter speed control, uh, and the third area is air supply, how we need to supply the fuel to air ratio, and that and the fourth one is about the ignition system, and the fifth one is about fuel delivery, and sixth one is about the control algorithms, and sixth one is about the monitoring and the feedback, and sixth one is about anti-icing systems, and the seventh one is about the pre-start checks. uh, these are the safety redundancy and simulation testing. And in this simulation testing, how we are using the FEM and this computational fluid dynamics for testing and simulation process, and the training procedures. And thank you.